In this video, we're going to tackle concepts in algebra. Specifically, we're going to tackle the idea of slope in applications. Three objectives here. We're going to be given a graph of a line representing an application. We're going to compute the slope of that line. We're also going to be required to state the units of the slope for that application. And then finally, interpret the meaning of the slope for that given application. So let's go ahead and take a look at the application that we're tackling here. Lisa is climbing up the side of a cliff. The following graph shows her elevation h above sea level t minutes after she begins climbing. So they tell us two things there. Well, they tell us actually plenty of things here, but two of the major items they give us is that this graph represents Lisa's height above sea level. I'm going to assume that's in feet, although some people might assume it's in meters. It's definitely not in miles. You're not 1,300 miles climbing something. So this problem requires some interpretation, but the elevation I'm going to assume is in feet, and the horizontal axis represents the number of minutes she's been climbing, so t in minutes. And that's h right there in feet. Maybe I should put that in parentheses. It's very common to put that stuff in parentheses. I'm being asked to do a couple things here. Compute the slope of this line and include the units in your response. Well, to compute a slope for any given line, you'll have to have 2 points. And we have a lot of points. There's an infinite number of points on this line. However, 2 have been highlighted for us. The first one here is at 50. That's the input value, and the output value is 1,300. So when we plug in 50, we have an output of 1,300. So I'll write the value of that point right here, 50, 1,300. The second point that's kind of highlighted here is at an input of 100, and remember those inputs represent the number of minutes. So at 100 minutes, and let's see what the output for that input is. Well, looks to be halfway between 1,300 and 1,350, which I'm going to guess is 1,325. It's actually a really good guess, right? That's halfway in between. So this is 1,325. At this point, we're going to use a slope formula. Now there's a couple ways you can imagine the slope formula. You could either say that the slope is change in y over change in x, or in this case, since we aren't dealing with y's and x's, change in the vertical variable, which is h, over change in the horizontal variable, which is t. Of course, some students don't like the delta notation. That's what those triangles are called, the deltas. So some students memorize this as h sub 2 minus h sub 1 over t sub 2 minus t sub 1. The best way, and I think the way that most students remember this, is that it's rise over run. So you'd ask yourself, if you were going from the point 50, 1,300 and ending up at the point 100, 1,325, how far would you have risen? Well, let's see. This distance right here, from a height of 1,300 to a height of 1,325, is a rise of 25. Or you could have said 1,325 minus 1,300, whichever. The denominator is the run, and the question is, how far did we run to get to that second point there? Well, let's see. Starting at 50, 1,300, I rose 25. And then I ran all the way over to the t value of 100. That's an increase of 50. Of course, again, you can always use the slope formula to write 100 minus 50. Take a moment to note here that if you are going to use the slope formula, which is always a good idea, you take the y values on top because those are the rise values. And the first y value you take, and I'm saying y when I should be saying h, the first output value you take, right below that, and I'll do that maybe in green, right below that in green here, is the corresponding input value, which is the t value. So 1325 over 100 minus minus, and then the corresponding output value 1300, that's the next output value, over its corresponding input value, which is 50. Just make sure you do that in order. If you don't, there'll be issues. So this is equal to, let's see, 1325 minus 1300 is 25, and 100 minus 50 is 50. And of course, you have learned how to reduce fractions at this point in mathematics, so you must reduce fractions. This reduces to 1/2. Now that would be the slope of this line, 1/2. Of course, we're also being asked to enter in the units. The units are not the variables. It's not h over t. It is rise over run, but you have to ask yourself, what are the units for the rise? The units for the rise variable are in feet. The units for the run variable are in minutes. So our units for the slope will be in the rise units, which is feet, over the run units, which is in minutes. Another way you could read that is 1/2 foot per minute, or 1 foot every 2 minutes. And in fact, that'll be used in our part B. Explain what the slope measures in the context of this problem. Well, she's climbing the side of a cliff. The slope of a line is also known as a rate of change. It tells us how fast she's going. She climbs she climbs at, there's a couple ways you could write this, 1/2 foot per minute. That's perfectly acceptable. That's called the unit slope. Or you could write, she climbs at 1 foot every 2 minutes. Both are perfectly acceptable.